Hi, my name is Kui Chin Yang. I'm a graduate student from NUS, majoring in knowledge engineering. Today, I would like to share with you the steps to solve any Sudoku puzzles systematically. Before we dive into the technical details, let's familiarize with the Sudoku terminologies. Squares, rows, and columns are self-explanatory. So for units, there are three configuration types, which are the columns, the row, and box unit. A puzzle is solved if the square in each unit are filled with a permutation of the digits 1 to 9. Here's a snippet of the units associated with square C2. For pairs of square C2, it is the list of all the squares in the three units excluding square C2. The Sudoku solver consists of two steps: constraint propagation and depth first search. The next couple of slides will cover the details on the implementation for each step. Constraint propagation helps to greatly reduce the possible solution space and in turn will allow us to arrive at the final answer quicker. As an example, strategy A1 is 4. That means A1 can only have 4 as its value, and we can remove 4 from all its pairs. As an example of strategy 2, as none of A2 through I2 except F2 has 4 as a possible value, 4 must belong to F2, and we can eliminate 4 from the pairs of F2. The newly filled square highlighted in blue is a result of strategy 2 as well. So the depth first search algorithm recursively considers all possibilities. Here's how it works. First, make sure you haven't already found a solution or a contradiction, and if not, choose one unfilled square and consider all its possible values. One at a time, try assigning each value and search from the resulting position. So by choosing a square with the minimum number of possible values, for example G2 highlighted in yellow, can increase our chances of getting the right answer. In this case, we stand a 50% chance. The next slide will demonstrate how the search algorithm works. So by assigning G2 to 8, G1 to 2, G5 to 4, so on, and finally A5 to 9, notice that square A6 has 0 possible values due to the upstream incorrect digit assignment. What happened next is that the search algorithm will try to backtrack and assign A8 to 9 and look for the next square with the minimum number of possible values, in this case A5. It is possible when G2 is equals to 8 leads to contradiction for all the solutions below. So the search algorithm will proceed with the right branch of G2 where G2 is equals to 9. Fortunately, since the first assignment is correct, the possible solution space is cut by half. With that, I will conclude my presentation. In summary, today we've learned about how constraint propagation helps to reduce the search space dramatically and how depth first search aids in converging to the final solution. I encourage you to watch the video links below where strategies similar to the Sudoku search solution was used. For the first video, cryptographers in Bletchley Park cracked the Enigma code during World War II, which was thought to be unbreakable. For the second video, it is described how an engineer was able to exploit security vulnerability of the safe and crack it in just 15 minutes. I hope you enjoy my video and have a nice day.